How you doing? My name is Brian Addison. I'm working with Malik Jones, and the topic of our project is Liverpool banking.
And before we got into our presentation, I just wanted to let you know that we made our own integration problem along with our own integration solutions to for those problems.
Okay, I'll briefly go over the overview. First, I'll go over the introduction. Second, the integration problem. Third, the initial messaging pattern. Fourth, brainstorming solutions. Fifth, the solution. Sixth, the conclusion. And seven, the references. And before I talk about this introduction, I'd like to give you a brief definition of what exactly system integration is. System integration is the process of combining components into one main system to increase the productivity by improving the quality of work. To give you a brief introduction of what me and Malik did, Liverpool Banking is a reliable banking app used by millions across the world for the purpose of checking their bank accounts from their mobile devices. For Liverpool Banking app allows customers to communicate with their Liverpool banking account from the comfort of their home. This messaging service provides each customer with information that pertains to their account upon request. All you have to do is send your requested information message to Liverpool's messaging routers, and the routers will contact its multiple databases and aggregate them to send each customer back their requested information. Okay, next I will go over the integration problem. So upon dealing with Liverpool's banking app, we noticed that there were multiple service calls duplications. Without proper applications, users receive data multiple times, and then and upon observation of their network tree, dependency was on two routers which was inefficient, which in turn aggravated customers, and then the business lost money. The question Liverpool's IT team had to answer is how will they avoid dependency across multiple routers and on all possible destinations while maintaining its efficiency.
All right. Here's a look at the initial messaging pattern that Liverpool banking was ran on. As you can see, it was too many servers. The data as customers sent data requests to Liverpool through Liverpool's banking app, they were sent through both Liverpool routers, which resulted in customers receiving data multiple times. And also their network at first seemed too crowded, just too much going on. So they had a hard time sending their customers the specific data that they requested. Instead, they were getting data that they did not request, along with the data that they did request. So that's the initial messaging pattern, as you can see.
Okay, next I will talk about brainstorming solutions. Our first step in brainstorming solutions, we will troubleshoot the network. Next, in troubleshooting, we observed the many problems. While troubleshooting, we noticed that the network tree was very crowded, which caused many problems. So, which leads to our next step, we focus on the network tree. Then we brainstorm changes as a team. And while troubleshooting and then focusing on the network, we came to a final conclusion where this network needed an aggregator. My partner Malik will go over what exactly an aggregator is in the next slide. And then lastly, we wrapped up our solutions.
So our next slide talks about the solution that we derived for Liverpool Banking's duplication problems and their data retrieving problem. That solution that we came up with was first we wanted to incorporate one main router that Liverpool Banking used instead of two, as you can see on this previous slide. Right here, as you can see, the diamond shapes represented our Liverpool banking routers. As you can see, is router A and router B, which which deemed was a problem for our customers. So then we wanted to incorporate an aggregator that can be used inside of the one main router that we will change. And the aggregator will basically, as you can see in the diagram below, will basically pull the specific data needed, requested by each customer, and then it would gather that data and push it through an input channel. Well, and this is all happening inside of the main router for our network. And by doing so, we will ultimately establish a less crowded network for our customers and for our business to run more smoothly.
Okay, the conclusion. A key takeaway, a human system integration is important in the early phases of the design process before needs are determined. As a team, we came to that conclusion because if Liverpool's banking IT team initially went over human system integration early, they would have noticed that, hey, the app isn't working correctly. It may be used in conjunction with other designs throughout the design lifecycle. Because with each step, you should always take into account of human system integration. It is also obvious that human system integration activities serve to mitigate human factor risk along the process, to make the human errors concerns at stake visible so that they may be considered when they trade off other design considerations. And what that means is they mitigate factor risk. So the user understands exactly when they use a specific application, what can't they do, what can they do. And next I will go over the new network tree, which got Liverpool's application up and running. A user opens the application using his or her cell phone. Next, the data is accepted by the input channel from the user. So then that is sent to Liverpool's routers. Then the router sends signals to the output channel to retrieve the customer's data. The data makes its way back excuse me. The data makes okay. The signal is then sent to a Liverpool router, that's where the aggregator does its magic. The aggregator basically relieves stress from the router, doing basically all the work. It channels each packet to its designated location, which causes less crashes, which focuses the packets to a specific database. So that's when then that is sent to an output channel, and then which contacts whichever Liverpool database the customer's information might be. And so that's when that is sent, the information from the databases is sent to the output data, which goes all the way back to the input channel, which is sent to a customer's device.
And like my partner said, once the data request is sent through Liverpool's router, the aggregator is working inside of the router. That's a part of the integration solution that we derived. The aggregator will work inside of the router and work through this output channel. And as the data request is sent through the databases, Liverpool's three databases, whatever data that is requested, the aggregator works inside of the router to compile that data and then send that data through the databases. And once it's compiled and sent through, it is sent through one of the output channels. The output data is then sent through back through the network and back through the input channel that the initial customer request was made through, and then back into the customer's device where they will see the message of the data that they requested only one time instead of having duplicate amount of text. And this will stop them from receiving data that they did not request in the first place. Running off one Liverpool router and also incorporating an aggregator inside of that one Liverpool router stopped our problems. And next, we will talk about the references that we use. There was about 4. We used these 4 websites right here. And that ends our presentation.
Thank you.